All right, so this is the third of 4 videos on the center of mass. In the first video, I talked about how to find the center of mass for a one-dimensional system where it's just either x or y. In the second video, I talked about how to find the center of mass for a two-dimensional system, so x's and y's, but it was still a discrete case like a scatter plot where I have individual dots. And I also talked about the definition of what a lamina is, and that's going to be important in this video because a lamina is still 2 dimensions, x's and y's, but it's more of a continuous thing where I can't like separate and pick out individual points. And so what I'm going to talk about here is how to find the center of mass, aka the centroid, for a lamina. And the first thing I want to talk about is how to find the mass of a lamina. And we're going to do that by saying capital M, the mass of the lamina, is rho, which is the density, and I'll write that over here. Rho is the density, and it kind of looks like a lowercase p without the stem on it, times the area. And we can find the area using calculus. And so we'll take rho times the integral from a to b of f of x dx if there's only one function in terms of x. If it's in terms of y, we can still kind of do the same thing. I'll do c and d of f of y dy because they may not be the same numbers. And if I have two functions, I can do a to b of f of x minus g of x dx, just like I'm finding the area between two curves, because that's exactly what I'm doing here. So if we're doing this in terms of x, f has to be the upper function, g has to be the lower function. If I'm doing y variables, f would be the right function, g would be the left function. If I don't know what rho is, we can just treat it like it's the number 1 and just kind of forget about it, because I'll show you in a minute that the center of mass calculation or the centroid calculation doesn't really matter what rho is regardless. Rho could be 5 and it's still not going to change anything if I treated it like it was 1. Now I'm going to go ahead and talk about the other two things. The moment of the system about the y-axis, which is my, and the moment of the system about the x-axis, which is mx. Now, when I talked about this before, we had individual points, which I'll just draw a couple of points here. And what we did was we took the mass of those individual points, and for the moment of the system about the y-axis, we figured out how far away it was from the y-axis and multiplied it by its mass. Well, now I've got a region. And so what I need to do is I need to, again, figure out how far away that is from the y-axis and then multiply it by its mass. So what I'm actually going to do, again, we're going to keep rho in the formula just as a placeholder. Again, if we don't know what rho is, treat it like it's 1. In the end, it's not going to really matter. And what I'm going to do is I'm going to do the integral from a to b, and in this case I'm going to use x values because, again, we're looking at how far away it is from the y-axis, and that x value tells me what it is. So x times the mass of it, which we're going to call f of x dx. And all that does is, again, summations and integrals are a lot alike. Summations are for discrete numbers, how many of them I can add up, whereas an integral would be more for an infinite summation. Now, this is going to be different if I have, again, 2 equations. The only thing that I'm going to do differently is instead of just doing f of x, I'm going to stick some parentheses around here and do f of x minus g of x dx. And that's kind of important for that situation. Now, again, this is if I do 2 separate equations. Again, f needs to be the upper function, g needs to be the lower function. I'm going to come back and talk about the if this is in terms of y in just a second. Now, the formula in this case is going to be a little bit different when I try to do the x-axis. Because again, if I want to try to figure out how far it is from the x-axis, I'm not actually going to use an x value. I'm going to be using y's here. And that's going to be the distance between the point in the region and the x-axis. It's going to be a y variable. And so honestly, the best way to do this one is if you could write it as a function of y, you could do rho times the integral from c to d of y times f of y dy. But the problem is, again, if you had 2 functions, you could do f of y minus g of y, kind of like what I did for the moment of the system about the x-axis, or excuse me, the y-axis. The problem is I can't always write it in terms of y. That's what I was getting at. And so there's going to be a slightly different formula if I have to use x. If I have to use x, we're still going to integrate from A to B, from the left number to the right number. But what I'm going to do a little bit differently is, and I want you to think about it this way, the y is oftentimes written the same way as f of x. And so what I'm going to do differently is I'm just going to kind of cut this essentially in half and say the center of mass is going to be somewhere halfway through my y values. And so we're going to do 1/2 of f of x squared dx. Now I'm going to kind of tweak this a little bit if we have two functions. It's still going to be rho. It's still going to be from A to B. It's just going to be 1/2 of f of x squared, and I'm going to use a big set of parentheses, minus g of x squared, and all of that is multiplied by 1/2. Now, kind of going back to what I was mentioning before is if I wanted to do this in terms of y, again, the moment of the system from x would be from C to D of just y times f of y dy. Or again, you could try to treat it if it's two different functions, you could do y times parentheses f of y minus g of y. Again, f of y would be the right function, g of y would be the left function. But if you wanted to do the moment of the system about the y-axis, you would do it very similarly to the way I just did the x's with the x-axis, is you would do c to d of 1/2 of f of y squared dy. And we're going to find the centroid the same way we've been finding it, which is to, x bar, y bar is my centroid, is my center of mass. We're going to take m sub y over m and m sub x over m. Again, because the moment of the system about the y-axis is actually using the x values. The moment of the system with respect to the x-axis is actually using the y values, the height. It's finding the distance along the y variable. Now, based off of this, if I do have rho, notice I have it in my formulas there for m sub x for the moment of the system about the x-axis. I also have it in the formula for m sub y, the moment of the system about the y-axis, and it's also in the mass of the lamina formula. Well, if you have these things all together, if you do m sub y divided by m, those rows are going to cancel out. If you do m sub x divided by m, those rows are going to cancel out. So in reality, the density of the lamina doesn't really matter when finding the center of mass or the centroid. Now I'm going to go ahead and move on and start trying to use these formulas because I feel like that's going to help us out a lot. And the first example I have is just a single function region. We've got 4 minus x squared, which I've already graphed over here to the left. And we're using this region that's in the first quadrant. And so in this situation, it's not going to be too difficult if I really want to switch it to the y variable. It's just not going to be something I necessarily want to do. So I'm just going to go ahead and do it with x. And so the first thing I'm going to do is find the area because it doesn't give me rho, it doesn't give me the density, so I can't technically find the mass. I'm just going to find the area. And so what I'm going to do is I'm going to do the integral from 0 to 2. So again, from 0 to 2. Those are my bounds of integration here along the x-axis, and we're going to integrate 4 minus x squared dx. All right, so now we're going to go ahead and do this. This is a pretty straightforward integral. So we're going to have 4x minus 1/3 x cubed from 0 to 2. I'm going to go ahead and grab my calculator, and it's 4 times 2 minus 1/3 times 2 cubed, which is going to give me about 16/3 is what I got. And remember, you could plug in 0, but it's not going to change anything because you're just going to be subtracting by 0. All right, now that I've got that one handled, we're going to go ahead and move on to the next one. So m sub y, what we need to do is, again, integrate from 0 to 2. And what I'm going to do is I'm going to take that function, the 4 minus x squared, and I'm going to multiply it by x. Okay, so the first thing I would do is actually just go ahead and distribute that x and make it 4x minus x cubed. Again, we want to integrate it. It's a polynomial, so it's pretty easy to integrate. We would just end up with 2x squared minus 1/4 x to the 4th from 0 to 2. I really just need to plug in the 2 because, again, if you plug in 0, it's not going to change anything. So 2 times 2 squared minus 1/4 times 2 to the 4th gives me an answer of 4. So that's my moment of the system about y. And for the last one, m sub x, we are going to do the integral from 0 to 2 of 1/2 of f of x, which is my function, 4 minus x squared. And I need to square that whole thing. So a couple of things. One of the things you could do is you could go ahead and pull out the 1/2. Just don't forget it in the end. I know I have a tendency to accidentally forget to include that. And I also want to go ahead and square that 4 minus x squared. Make sure you don't just distribute the square. Make sure you actually multiply it together. In this case, you get 4 times 4, which is 16. 4 minus x, 4 times negative x squared, and negative x squared times 4 gives me negative 8x squared. And then negative x squared times negative x squared is going to give me positive x to the 4th. So that's what I'm going to have here. 16 minus 8x squared plus x to the 4th. And I still need to integrate that. Again, I need to keep my 1/2. Otherwise, I tend to forget it sometimes. So that's going to give me, I don't know why, I'm going to erase that. 16's integral is going to be 16x minus 8/3 x cubed plus 1/5 x to the 5th. And we're integrating or evaluating from 0 to 2. There's no real point in plugging in the 2. So let's see, if I do 1/2 of whatever that is, let's see, 16 times 2 minus 8/3 times 2 cubed plus 1/5 times 2 to the 5th is going to give me 256 over 15. That's a really big number. Let's erase that. 256 over 15. And if I divide that by 2, I get 128 over 15. All right, so that's my m sub x value, my moment of the system about the x-axis. So I'm going to go ahead and start finding my center of mass, my centroid now. And what I need to do, again, is take these two things, m sub y divided by my area for the x value, and m sub x divided by the area for the y value. Again, if I knew what rho was, I would multiply everything here by rho, but it would eventually just cancel out anyway, so it's not particularly important. So let me just go ahead and do this math here. So we're going to do 4 divided by 16/3 and 128 over 15 divided by 16/3. 4 divided by 16/3 is going to give me 3/4. And let's see, 128 over 15 divided by 16/3 gives me 8/5. Now, I think it's kind of important, especially when I'm doing this. I always like to graph it, and the reason I do that is because I can always kind of eyeball it to make sure I've kind of done this correctly. Is it kind of makes sense that, you know, if I'm looking at x values between 0 and 2, that 3/4, which is 0.75, is kind of close to where it's supposed to be. It's kind of halfway across. My y values are from 0 to 4, so 8/5, it's kind of not too far from halfway across. I think it's also important to realize that because this is in kind of an unusual shape, it's not going to be exactly halfway on the x-axis and halfway on the y-axis. It actually ends up being at 0.75 and 1.6, which is right about there, which I'll be honest with you, it kind of looks right to me. Just I didn't draw it completely perfectly, but it looks like it's somewhere about in the middle of that region, which I'm going to go ahead and say is good. The other one that I want to do is one that actually uses two functions, and I tried to pick two functions that weren't too ugly to deal with. I used y equals x and y equals x squared. Notice my x values go from 0 all the way over here to 1. And so that's going to be when I try to find my area, what I'm going to do. Notice that y equals x is the one on top and y equals x squared is the one on bottom. So I'm going to do x first and x squared second. So we're going to integrate from 0 to 1 of x minus x squared, and this should give me my area. So when I integrate this, the x becomes 1/2 x squared. the x squared becomes 1/3 x cubed, and we are integrating again from 0 to 1. So I really just need to plug in the 1, which is 1/2 minus 1/3. Let me figure out what that is. 1/2 minus 1/3 should be 1/6. Excuse me, it is. And so there's that. All right. From there, I need to find m sub y. So what I'm going to do is I'm going to integrate from 0 to 1, and I'm going to multiply x times x minus x squared. So I'm doing the x value times f of x minus g of x. So I'm actually going to distribute this x this time. I did it back then in the last example too, but that was just a much more complicated function. So let's see. When I do this, I'm going to end up distributing, like I said, and that's going to be x times x, which is x squared minus x cubed. When I integrate this, the x squared is going to turn into 1/3 x cubed, and that x cubed is going to turn into 1/4 x to the 4th, and we are evaluating from 0 to 1. If I plug in 1, it's just going to be 1/3 minus 1/4, which I want to say is 1/12, but let me just double check just to be sure. 1/4. Yeah, I got 1/12. So 1/6 divided by 1/12. So we're kind of moving along nicely there. And for the last one, m sub x, we are going to integrate again from 0 to 1 of 1/2. And what I need to do is I need to square these two things separately. So I'm going to do x squared minus x squared squared. So I'm doing 1/2 of f of x squared minus g of x squared. And so I'm going to go ahead and square those, and I'll take out the 1/2 again. Just don't forget it in the end. It's going to be kind of important. So x squared minus x to the 4th. If I integrate x squared, again, don't forget your 1/2. X squared is going to turn into 1/3 x cubed. X to the 4th is going to be 1/5 x to the 5th. We're integrating or evaluating from 0 to 1. So that's going to be 1/2 of 1/3 minus 1/5. Let me go ahead and figure that out. 1/3 minus 1/5 should give me 2/15. And then I divide by 2, which is 1/15. So that's my moment of the system about the x-axis. And again, to find the centroid, we need to divide first m sub y divided by the area or divided by the mass. And then for the y value, we're going to do m sub x divided by that. So we'll do 1/12 over 1/6, comma 1/15 divided by 1/6. And if I go ahead and do that math, 1/12 divided by 1/6 gives me 1/2, which kind of makes sense by looking at this, is that it should be kind of somewhere in between 0 and 1. 1/2 is about halfway across, so that's not too bad. And then the other one I need to do is 1/15 divided by 1/6, which gives me 2/5, which is about 0.4. So that's not all that particularly surprising that it's at about 0.5 and 0.4. Notice it actually is in this region because y equals x would have the point 1/2, 1/2, and y equals x squared would be 1/2, 1/4. And so I should be in between those two numbers, which 2/5 is between those two y values. So that's kind of an important thing to recognize, is to make sure that my center of mass actually is in the region. I've had a few times where students have done these problems and they've gotten something that, their calculations, they, get kind of messy and they make some mistakes somewhere along the way, and their center of mass actually ends up outside the region. It's always a good idea just to kind of look at the graph and say, hey, does this actually look like it makes sense? Please feel free to let me know if you do have any questions. Hopefully this does help you get across what all your formulas are, because again, this is the real calculus stuff. Hopefully you got this. If you don't, let me know. I'll help you with whatever I need to. Have a great day.